Okay, perfect. So, as I say, my name's Steve Shaw. I'm going to talk about a project written in Pickle TK called HammerDB. As an introduction, I'm the database technology manager at Intel. So I've written 2 books, on Oracle. So I think that's one of the key things really, is that I'm more of a database guy really rather than a developer. HammerDB is an employer-approved open source project. So I first used Pickle way back with Oracle 9i Enterprise Manager. Some of the background, I started off having a discussion with Steve Huntley about something on the Ticklers wiki, where he said the project was successful, but it was well hidden, so I wanted to update that. So I had a conversation with him, which led me to update the wiki and submit this presentation. So hopefully I can talk a bit about HammerDB. So what is it? Also, I'd say as well, if you've got questions and things, feel free to interrupt me as I go along. I like to sort of keep it interactive if we can. So it's an industry standard benchmarking tool. So if you have a look at that particular link, there you can actually see that there's a number of benchmarks that people have taken and actually using HammerDB to test their database-based environment. So here's some examples as well. So from HP, we've got Google as well, and also probably the biggest of them all, which is Oracle. So I'd say with Oracle as well, I mean, that's a good example. It's not actually an Intel-based workload, so that's testing Spark-based systems. So there isn't particularly a bias there towards Intel as such. It's more of a tool that you can actually take and test any database environment. And it's gained, as you can see, hopefully it's gained a certain degree of popularity, over the time that this tool has been available. So why HammerDB? I think that this is probably a good question. Why the tool in the first place? Well, traditionally with databases we have the TPC, so the Transaction Processing Council. You can see an example there. So what the old way is, you've got the big companies, big database companies, they'd submit official audited benchmarks. One example, that's the example of the last official benchmark based on an Intel platform, cost $4 million to do. It's on a bare metal environment, and I think when I last looked in 2014, there was one official TPCC benchmark. So these benchmarks that do both OLTP and data warehousing as well. Whereas with the new method, with HammerDB, really enables people, so it takes the essence of these benchmarks and enables people to run their own transactional and data warehousing type benchmarks in their own environments. Because it's open source, one of the key things is zero cost. Also computing models has changed. So whereas we used to have, pretty much, if you go back 10, 15 years ago, one CPU, probably only a few SKUs, available, a bare metal environment. Now we have cloud, we've got virtualization. I think at the last Intel, certainly for the Xeon series, we've got over 40 different SKUs for the processors. So it really needed a new approach. And I think the description, here by one of the people using it is a great description that they put online, probably better than I could do myself, where I'd say faster and cheaper has much greater appeal. You can also take the results now and put them on social media. So things are just moving quicker. The environment of database benchmarking has changed over time, and HammerDB has really sort of fitted into the way that things have changed. So, of course, from a Pickle viewpoint, what actually is HammerDB? So, as I've said, it's a GPL project, so it's open source. I make it available pre-compiled as well. So it's important that most users don't know Pickle. I'm probably not even aware that the tool's written in Pickle. So I make it available pre-compiled on Windows and Linux. It would run on any other platform, but it's just the case that I have Intel-based platforms to be able to compile and test on. And it's importantly looking ahead that you can test. But it's worth noting as well that the databases that it runs on can be running on any platform, so you can test against a mainframe, Spark, Power. It works typically in a client-server type environment. So it's got a TK GUI, using some tile-based themes. It's got a script editor, so it's actually a Pickle script in the middle, so it uses the C text for highlighting. Then that script is posted to what the user sees as virtual users. So the virtual users are actually Tickle threads running in the background. The output's monitored in a table list, so every individual thread reports its status back out to its entry within a table list, and then there's an inbuilt TKCon console where any errors from the threads are then reported out into that console. So from the databases and the extensions that are used, so it covers the most popular databases. So right at the top there, Oracle and times 10 uses EuroTcl. It's worth noting as well, as I say at the top there, so all the extensions I've taken, I've compiled them for Linux using GCC and on Windows using Microsoft Visual C, C++, which has involved a little bit of working because a lot of the packages don't necessarily support Windows out of the box. So with Oracle, it uses EuroTcl, and that wraps Oracle's own OCI-based extension, their low-level C extension, so it's using all the native APIs. So we have SQL Server. I say that on Linux and Windows, so I think it's a good example of the approach that SQL Server, I don't know of any other tools that support SQL Server on Linux at the moment, so this can have a pure Linux client running against SQL Server on Linux if you wish. So that uses Pickle TDBC, again compiled up for both Linux and Windows. With DB2, there was a package there that took a bit of changing and updating to bring it up to date. I've also modified it to add what's called bind variable support, which is important for database performance. So that is there. Not the same as what's officially available, but I've updated that package, especially for the performance. Then we have all of the MySQL family, then also the PGTcl for Postgres. Now these support, it's worth noting, I'll say, these support and work against the Amazon-based cloud products as well. So for example, if you want to test Amazon Redshift, you can use the PGTcl client, the Postgres client, and actually go in and run data warehouse type workloads against Amazon Redshift. And then there's Redis and also a SQL on Hadoop workload, which called Trifodian, which originally came from HP, which is why that one's there. So it probably helps if I give an example sort of walkthrough so you can have an idea of what the tool does to then provide some of the context for what sort of lies underneath it and why Pickle was used to actually write this application in the first place. So I don't know how clear that it is, but you have a menu, a sort of a tree-based menu on the left. You then select your particular options for your database. So the options then come up in a GUI-based environment and allow you to make sort of common sense decisions with what you're choosing. So as one example, just there, we haven't selected in-memory OLTP for this particular SQL Server schema. So then, those options for in-memory OLTP are grayed out. So if somebody's a database user, it then allows them to make the right decisions to go through the build. You select OK, you can confirm the build. And then what that does is it loads into the script monitor, essentially build script. It automates all this. So once you've clicked OK, and it then posts that script out to multiple threads. Again, not sure how clear it is from the screen, but you see all the different virtual users or all the different threads do different actions depending on their position within the thread list. So the first one monitors the workload, creates all the individual tables, then you get the other virtual users or the other threads, then take a chunk of the database and then load it and insert the data, all in parallel. So you're getting a good performance, in terms of the actual build. For the cloud-based environment, there's also an option where you can just generate right out the data into flat files. So all this data is being generated with Pickle and then being inserted into the database with Pickle. Also, as it says on the left, T-SQL, we're creating stored procedures which are then being called and generated within the database within their own native languages. So I probably spend a lot of time tuning and writing the database part of the workload as much as I do with the Pickle part of the workload. And then finally, hopefully, as you can see, the different threads, they report the status. You get a nice green tick and it says the schema is all created and ready to be tested. You then have the options where you can configure the driver. So in this example, same sort of approach. You choose your particular workload, whether you want a timed workload or really a test one. You set up your details for the ramp-up time, the test time. This then loads a driver script. You configure your virtual users. In Pickle approach, that's configure the number of threads that's going to run. And then you set it up, you run the workload. And similarly with a time test, you've got one virtual user do the monitoring and the other ones go ahead and run the actual workload. So with that as the context, the question is why use Pickle for database benchmarking? You know, of all the tools and the languages out there, I think the real key to this comes down to the one interpreter per thread model. So what we're doing is we're taking the very lowest level, you know, API from the database approach. So in this example, you know, even Oracle have said they're exposing the full power of the Oracle database using the Oracle call interface. So you've got the OCI interface in this Oracle example, or the native APIs with all the other databases are being wrapped by the Pickle commands. We've built the database, we've built the schema. Most of the workload takes place within stored procedures within the actual database. So these virtual users, essentially created out with multiple threads, they're all calling these stored procedures on the database. So this enables us to be able to run databases up to, as you see from the CPU monitor, you can see how clearly that is on the side, up to tens of millions of transactions per minute. And when I say a transaction, that's running through a whole stored procedure and doing a commit. So that's not just like one select or one update, for example. That's running through a whole stored procedure, you know, and then doing a commit, handling all the locking, you know, all the loading, commits, rollbacks, the whole thing. You can also, the virtual users will check to see if you've aborted the script as well using the thread shared variables. Or if you want, you can actually, once you stop the workload, you can then kill the threads as well. So you have that management within a typical sort of, you know, load testing environment. And using the Pickle-based approach, I like this commercial comparison. You probably can't read it directly there, but somebody from, you know, a commercial tool, you know, essentially is, you know, has put a comment there. They're running commercial tool and HammerDB, and HammerDB, you know, uses a lot less CPU and produces a lot higher performance. And I think all that comes down from the use of Pickle, you know, as the back-end engine for really driving these database workloads. So for some other features in there, you can probably see that the Pickler's wiki, you know, features, you know, heavily in some of these to give the original, you know, ideas. So there's a transaction counter, so it connects up to the data within the database, pulls out the transaction numbers, and then produces these on the screen as a moving transaction counter. So the one on the left, it shows a nice example of a ramp up as we're warming the cache. So as the database, you know, is loading the data into memory, it's starting to build up, you know, we're warming the cache and seeing the transaction rate improve. So usually you'd run a test, and when you see that rate as being nice and flat, then you know you've got a good database configuration. This runs in a separate thread and is based on the emu graph and also I think the ribbon graph as well. And you can drag these out in Windows, they're detachable windows, so you can watch the transactions. Also, there's a CPU monitor as well, because it's very useful when you're running database workloads to be able to see the performance per core. So for example, I was running one test, running the CPU monitor. Core 0 was a lot lower than the others, which then let me look in and I could see all the interrupts were being handled by Core 0 on the database workload. Fix that, comes back up and the performance shoots up. So, and especially on Windows as well, I won't go into the whole detail of processor groups, you know, when you get more than 64 logical CPUs, but it's a very nice way to see what part of your system is being loaded at a particular time. So that runs by MPstat on Windows. I've written MPstat in Pickle and it uses the TWAPI extension to be able to essentially tap into the same information to give you that CPU monitor. But and it runs as an agent on the server that then passes the data back to the client. So it's really more sort of, you know, server driven. So once you've run a test, you know, importantly, you get the outputs. We're on the Oracle version. It's also linked in where it generates an Oracle performance report. So the Pickle script generates the performance report. it reports out the data. In this example, fortunately, that matches up to what the database says the performance is. So this particular example, right at the bottom, it says 41,000 transactions per second, which matches up to what HammerDB reports. So this is about 2.4 million transactions. This is on a few generations back on a 2-socket server now. So it's an example that we're producing a lot more performance through this application. We've not reached the limits of what the client can do. We're always pushing the server. Another feature as well, probably one of the things that makes it reasonably popular out there, is there's an autopilot feature, something that Pickle makes very easy to do, because essentially provides a timed virtual user or virtual DBA to run the test. You give it a sequence of the number of virtual users you want to run for each test. That's timed, and then it essentially presses the buttons, stop, create virtual users, run virtual users within that time sequence. And that produces, the idea is you produce like a performance profile. So you can just leave, once you've done that, once you press the button, you can leave it. So, you can go to the pub, you can go home, come back the next day. It will run that test for you over a number of hours, which is something that can make your workload a lot more productive. Or even the working day, you can set up your tests and go and do something else and get all the results back from the log later. Also, another Pickle-enabled feature is there's an option to connect multiple clients together. That uses the COM package and send, which was fairly easily to implement, because essentially you press a button, send the command to press the button on the remote client, so you can join multiple clients together, control it from one place. And then that's useful, especially if you're testing a cluster like Oracle RAC and want to direct exactly the same workload to each particular node, or virtualization as well. You want to test multiple VMs in one environment. You have one point to control it, and then you can run, for example, and it works with the autopilot feature, so you can test multiple VMs all at once. So the example use where we use it in Intel, there's a lot of use with partners. One example with HP, they're the ones who asked me to enable SQL Server on Linux for them. Within Intel, we use it in multiple groups. One of them is doing database performance tests on upcoming processors. So as you can imagine, there's a lot of tests that get performed. This is one that sort of validates what the official TPCC benchmarks do. And then we can also run what we call downbin CPUs, do the same tests on multiple SKUs. So the chart, unfortunately, because potentially we can't share all the data, but that's an example of previous generations. The example I say we haven't got the upcoming one. We've already done those for the Skylake processor. Those are not on the chart there, but this shows the actual slides. This shows the examples of the different levels of performance between different generations. Exactly the same Pickle application. The difference is that we're getting better performance on the database side. So it's used so we can know ahead in advance and also troubleshoot and see what the levels of potential performance is. And we can take that data, use it internally, use it with customers, so we can then right size database workloads and applications per CPU. And I think it's a nice example from the testing to show how Moore's law within database performance on the different generations keeps carrying on apace. Some example use, so I mentioned at the start, it's been called an industry standard tool. Okay. So example use externally, we can see there's a number of people recruiting for skills within HammerDB, and also you can see if they're recruiting for that, they're also recruiting for Pickle skills as well. So they're very useful because you've got the script editor. You can go in there and change anything that you like. Just to wrap up, so we have ongoing development now. So it grew organically, I would say, from an application called Hammerora, originally for Oracle. I was asked over time to add in support for different databases. So it now supports the top 5 relational databases. As you can see, there's a website called DB Engines, which lists out databases in terms of their popularity. It's interesting that the top certainly the top 10 is dominated by relational databases, and HammerDB now supports all the top ones, so probably covering about 99% of the database user base out there. I get a lot of requests to add in additional databases as well, so one thing that is ongoing is some sort of refactoring to move away from that organic growth approach to separate it out into a lot more distinct areas. So I've taken an approach now of separating out individual XML files. That gets turned into dict-based data inside HammerDB to then separate out how the data is stored per individual database. And now you can add your own database, just add the data to the configuration file, and then that now appears within the application, which makes things a lot easier. Other planned development, so I say really just to wrap up, there's so many ideas. It comes pre-compiled. I say I'm on 8.60 at the moment because there's a lot of testing that needs to take place. When you have, I think it's 7 databases and even more, 2 workloads each, there's a lot of testing that needs to take place to make sure, especially when you're benchmarking, because you want the performance to be exactly the same, and that's one of the key things about a benchmarking tool. It has to be accurate and repeatable. You get the performance results for one workload. You want to get exactly the same if you run the same test on the same system at a different time. So that's why it takes a long time for testing to be able to get to upgrade things. There's a number of idiosyncrasies, because I say it's grown organically from initial tools, so I know there's things that need tidying up, applying more, make it more user-friendly. There's also one application which is called Ashmon. I've spoken to the author, and he's given me permission to add this in for monitoring Oracle-based workloads, but at the moment that uses BLT. So that uses TCL 8.4 using BLT, so to add that in I need to look at the whole updating that environment. It'll be a great addition to the tool for monitoring, but that's some work as well, and it'd be great to have that included within the next version. Also, a final point, there's a lot of documentation because people using this tend to be database people. Databases tend to be pretty complicated things, so it's been a real important part of the project to have extensive documentation. So I spend probably as much time writing that as I do actually writing any code, as well as all the other time I do doing my sort of regular job within Intel. And I think we're just sort of coming to the end of the time, so have we got time for questions?
I have one question.
Yeah.
You wrote on one slide you had EMU and driven graph. What is that exactly?
So the EMU graph is a pure TCL-based graphing application that's been around for a while. So it produces static graphs, static line graphs. There was also another, I think on the Tickler's wiki, some nice ribbon graphs produced for something. So I combined the two, but then essentially the approach it takes is it draws a graph, but it keeps a sliding window of transaction data. So it connects to the database, grabs, in the Oracle context, it does a select, user commits plus rollbacks, grabs that number, adds it into a TCL list, and then provides that list to update the graph. You wait for the refresh 10 seconds, it then updates the graph. You've got fresh data within the list, so then the graph changes. So that approach then produces a nice ramp up, and it will go along. And hopefully the idea for the user is you see a nice straight line. So you ramp up, you see a nice straight line. It's a very useful way with database performance where you see, if you see peaks and troughs, or quite often in database terminology, you'll have a checkpoint where you write out all the data and you'll see the transaction counter go boom, down and go back up. So the idea is when you run a test, you get good performance if it's going straight. But EMU graph is just a pure TCL graphing package. So it's not compiled, it's just all written in TCL.
And the ribbon graph is also pure.
Yeah, that's also pure TCL. But what I've done is I've brought the two together. So it's the EMU graph with the ribbon graph on top, and then added it in so it's moving. So it's taking good ideas from other people and plugging them together for what I need to do.
Oh, I'm missing SQLite.
That's one I've not been asked for, but it's in the top 10. But the approach, that's very much the thinking behind the next version is at the moment from that organic approach has been quite difficult to add different databases. So if I break it out, also if anybody wants to add their own database, it should be a lot easier to do so because you just add the config in XML files and then it will broken down a lot more logically on what you need to add in a database workload, because there comes to a point on DB engines there's 328. So, you know, if it takes me, say, 6 months, you know, that's a long time to be able to add in all those individual workloads. So that's the approach.
Where do you keep the results of the benchmarks? You show them there in the graphs, but where do you keep the results?
Well, people, again, a lot of people now with the new approach, you know, put them on social media.
No,
So
technically, do you write them to a file or?
oh, sorry, so there's a log file.
Mm-hmm.
So it reports that, so it will write out to a log file. When you show the Autopilot screen as well, it comes out within there. So, but generally you just say write it out to a log and it keeps it within a text file, and you get the results of the transactions per minute, which is database specific, but then new orders per minute, which is database independent.
Mm-hmm.
So it reports two values, but one where you can compare databases, the other one is just comparing one database to itself on different systems.
So if there are no questions anymore, I would like to thank Steve for your very
Okay.
interesting talk.
Thank you.